Hello, and welcome to Securing Smart Meters with MULTOS, an overview highlighting some of the challenges around this particular security infrastructure and how MULTOS seeks to overcome them. Building the foundations of a security infrastructure in smart metering and power networks is a monumental task. There are similarities with the national grid network itself. Large, high-voltage cables are complex, expensive pieces of infrastructure. Essential to the overall scheme, but need to be installed once and then forgotten about, remaining in place, performing their task with little to no interaction. Security infrastructure should have a similar thinking behind it. Once in place, it should be relied on as a solid grounding for all future developments in the industry and not require tinkering and reworking as markets grow and evolve. This presentation is to demonstrate how MULTOS can provide a secure platform for metering infrastructure, how it is already doing so in other markets, and how it can be implemented today for the systems of the future. There are many communications technologies, Zigbee, Wi-Fi, GPRS and 3G to name a few, currently in use or being considered for use in metering communications networks and the IoT or Internet of Things. All have varying levels of security, but also have well-documented flaws. Disparate protocols and mechanisms serving discrete portions of the network leads to at best overly complicated systems management issues and at worst inherent security fallibilities. This weakness highlights the need for a single overarching security infrastructure to guarantee compatibility and invulnerability across the entire network. MULTOS is a highly secure operating system for smart devices. Developed originally in the UK for the banking industry, it has also been adopted by other industries requiring the unparalleled security and interoperability it can offer. MULTOS is used extensively in payment cards, national ID cards, e-passports and transit applications worldwide. As of December 2013, there are in excess of 500 million MULTOS devices issued globally. As well as all the major worldwide payment schemes and numerous country-specific schemes, a number of governments are using MULTOS as the platform for their e-passport, citizen ID, driving license, physical access and other use cases requiring a device that can securely hold multiple discrete applications. MULTOS meets these demanding criteria, making it an ideal choice for securing high-value infrastructure-critical assets such as are found in a power distribution network. We shall now see how the features of MULTOS can be used to alleviate security problems associated with smart meter networks in particular. There are several key instances during the life cycle of a meter when the ability to verify unequivocally the meter is not only a genuine device but also is the specific target device is critical for the safe transfer of keys and data. The authentication of the meter is required when loading firmware and/or keys for the first time. The meter may be installed in a blank state. Once the customer has selected their energy provider, the related firmware can then be loaded onto the meter. Updating firmware and/or keys to the meter in situ. Changing energy supplier, updating tariffs or closing accounts are all examples of when communicating with the meter remotely is desirable. This new or revised data will require the meter to be authenticated before communication can take place. Taking readings. To ensure readings are genuine and coming from the target device, any communication from the meter to the host system will need to be verified as genuine. And issuing commands to manage meter functionality in situ. Any command that can be sent as a control on the meter functionality, whether it be for the firmware or indeed the functionality of the meter itself, requires the device to be authenticated beforehand. MULTOS is based around a complete scheme, ensuring logical and physical security of hardware and software throughout their whole life cycle. Core to this scheme is the MULTOS Key Management Authority, or KMA. Housed in the most physically and logically secure commercial facility in the UK, it has, as has been discussed before, trusted to manage the keys and digital certificates of numerous financial and governmental institutions globally. The KMA fulfills the role of trusted third party, the root of trust, that is the bedrock of any such security infrastructure, generating and certifying all keys for identifying and awakening, called enablement in the MULTOS scheme, a MULTOS chip, as well as for loading firmware. MULTOS alone, of all the smart device platforms, mandates that every single chip is injected with a unique transport key and serial number at silicon manufacture. This identifies and protects each individual MULTOS chip and makes it distinct from any other chip. Obtaining the key for one chip compromises that one device alone and not all devices from that batch, as would be the case with other platforms. The transport key allows the devices to be moved from silicon provider to meter manufacturer in an encrypted state, providing further protection. Enablement sets the owner identifier and product identifier, e.g. to identify the model of the meter, and also includes a unique asymmetric key pair and public key certificate used for loading and deleting firmware. Included in this certificate are the owner identifier and device serial number, making it possible to check if a MULTOS chip and, by extension, the meter, is genuine by verifying the public key certificate with the KMA public key. Once the firmware is loaded to the MULTOS chip, any desired secure protocol implemented can be reliably used to verify the authenticity of the meter. The MULTOS security environment has been tried and tested in more than 500 million devices worldwide without a single tamper breach. In fact, some MULTOS products, specifically for the national ID market, have an EAL7 rating, the highest of any commercial available product. The demands of the payment industry in particular have driven the cost and power requirements of devices lower and lower, already satisfying two important commercial criteria of the metering market. MULTOS was designed so that each application resident on a device operates within a predefined memory area. MULTOS guarantees that the application and the memory space within which it operates cannot be tampered with. Any attempt to do so will append or stop the application. MULTOS also guarantees that an application cannot modify or access another co-resident application, that is, applications that are loaded and run on the same chip independently of each other. MULTOS has a unique mechanism for loading and deleting applications from devices. In other platforms, a secure channel needs to be established between the host system and the device before data can be sent to the chip. In the case of MULTOS, the data is created, personalized and encrypted offline before being sent to the device. Each packet of data is encrypted by the target device's own public key and can therefore only be opened and loaded by the target device. This has huge implications for key management. In the case of MULTOS, there are no keys to manage. They are all held on the device and are unique to that device. Data can be uploaded to any insecure environment, awaiting the unique target device to pull it down, decrypt and load as required. MULTOS mandates all load and delete actions require a valid load or delete certificate issued from the KMA. These certificates provide the authenticity of an application, its integrity and the right to be loaded or deleted onto the target chip. Load certificates contain the firmware identifier. Each certificate is specific to a single firmware identifier, and this is checked against the identifier of the firmware package. The owner identifier. This must match that loaded into the chip during enablement. This gives permission for the firmware to be loaded. A hash of the code segment of the firmware, to allow the chip to check the integrity and identity of the code specifically. A list of valid products. It is possible to ensure that firmware can only be loaded to particular products as defined in the chip's enablement data. A signature of the whole firmware package using a firmware signing key. The signing public key is also contained in the load certificate, allowing the chip to check the firmware signature when loading, guaranteeing authenticity and integrity. And optionally, the serial number of the chip the certificate is for. Usually, certificates are issued for a whole class of chips belonging to an owner, but it is possible to issue and therefore control loading permission at a per-chip level. Confidentiality of the data contained in the firmware load package is achieved by encrypting the data with each chip's unique public key. In that way, only the target chip can successfully decrypt the confidential data, as only it has the corresponding private key. If firmware for an external chip needs to be updated, it is possible to use the MULTOS chip to provide the cryptographic validation of that external firmware. Because you can securely load the MULTOS chip's firmware, you are able to trust it fully to validate the external firmware. Using MULTOS simplifies the process for downloading firmware images and eliminates any concerns around secure handling of firmware updates in transport, as they are cryptographically protected from source. There is no need to define a totally new process or build a completely new infrastructure to support it. The mechanism, unique to MULTOS, for loading and deleting allows firmware updating to be handled in exactly the same way as loading new firmware. When deleted from the device, the MULTOS firmware is deleted in its entirety, allowing for an updated version to be installed without the fear of backward compatibility issues. This also means the owner of the firmware, for example a utility company, does not have to be concerned about portions of their code remaining unsecured on the device. If a customer changes energy supplier, the old supply code is removed completely. Any secure protocol running within the firmware loaded into the MULTOS chip will use cryptographic keys, for which MULTOS provides an ideal secure platform for populating and storage. The firmware package can contain data which can include keys specific to the firmware, which can then be encrypted using the individual public keys of the target chips. This ensures their security whilst residing on the device. The MULTOS consortium has more than 30 members, made up of global blue-chip organizations, between them providing comprehensive coverage for every aspect of the MULTOS scheme. Thank you for listening. For more information, please visit www.multos.com or contact the Mousco team.